Okay, so this is where we left in our previous lecture. So in short, what we have done is that we have created our data access object, which is basically connection or a way to communicate with the server. So a way of accessing objects. We have created our transfer object, which is basically image of the object on the backend with the data that we need to be transferred from the server to our application. We have also created our retrofit client to be used for sending API request. And now is, I believe, the great time to start talking about Room database. So firstly, we'll open Gradle and we will need to add dependencies for Room. We will click on Sync Now. So Room is basically a library that provides us some abstraction layer which wraps SQLite so that we can have easy communication and easy operation with it. You know how SQL helper was a bit annoying with that boilerplate code where we need to instantiate it. We need basically to implement all kind of logic of how the data will be retrieved from the database. So with Room, things are quite simple. So firstly, we are going to create package Room, and we will create class called database. It needs to extend Room database. Now it says that it must be either declared abstract or to implement some kind of methods. So that's why we'll make this class to be actually abstract. So object of this class needs to be singleton as well, but since we will need to provide context when creating this object, we can't instantiate it right away, like in previous singletons in this project. So we will simply say private static database instance, and we will add public static get instance, which will accept context in here. We need to return database, and the instance will be created in this way. Room.database builder. We need to pass context. Now we need to pass database.class and name of the database. So we will call it picture items database, and we say build. So now to make this singleton thread safe, as we discussed previously, we will make this method synchronized. So what this synchronized mean is that only one thread can access the code inside it at a time. So basically, if two multiple threads call get instance, first thread who calls it will continue with code execution, but the second one will wait for the first thread to release the lock, basically. So after first thread finishes execution of this block of code in here, only then second one will continue working. So that's why we'll here add check. If instance is null, we will create it like so. Otherwise, we'll just return instance. To explain it a little bit deeper, so why are we using synchronized singleton? So basically, if we're not using synchronized in here, if two threads call get instance in pretty close same time, let's say, both thread will see that instance is null and will create database builder and return different types, different versions of database, let's say, different objects. And if this is synchronized, when first thread comes in, second thread must wait. So first thread will say, okay, instance is null, I will now create it and return it. Then second thread will say, okay, now I can go inside. Okay, instance is not null, so I will just return the instance which was created by some other thread. And we'll also add private constructors so that nobody can, or actually maybe it's not even needed since this class is abstract, right? So no one can instantiate database. We will just confirm it now. It says it's abstract, can be instantiated. So that's why we don't need private constructor in this case. So now how to let database know what kind of tables do we want inside? So for that purpose, we need to add a notation here, which is called database, and we specify entities. So entity is object which is inserted in a database. So basically all items within database, when we're talking about local SQL database, are representing different kind of entities. So if we want to save some user inside our database, it's one entity. So user object would be entity object. So since in this case we want to put picture items inside, we need to create object that will represent that entity in a database. So we will create package called entity, and object name will be picture item entity. Maybe you can call it picture entity, however you want. So now to mark this object entity, we need to add this annotation. So now we can come back in here and we say that picture item entity will be entity in here. We must use curly braces in here to specify that if we have more entities, we can add them in here like this. What we also need to specify here is version of the database. So initially version is 1, and when we want to change schema in our database, so let's say that we want to add a new column, we want to edit something in it, in its structure, we would need to upgrade version in that case. Otherwise app would crash, it would have thrown error which would say version is the same as previous, but I see that there are some changes in the structure. So now how this database knows name of the table? So basically in here we need to specify table name, picture items. So now we want to do something similar that we did in our picture item data transfer object. We want to have those fields as well, but there is no serialized name when it comes to SQLite database, but instead we have primary key so that it knows that this will be an ID that will be unique for a specific item. We will have author and we will have image URL. Now Room will automatically generate column names according to the fields that we specify in here, unless we specify column info name to be something different. So we want to keep the same. Also, know that primary key accepts auto-generate attribute. If we leave it true, it will automatically increase. It will basically generate it for us if it is string, if we don't specify it, so that this item becomes unique. We will remove this because all IDs from the backend are already unique and we want them like they are in our database. Now we must provide constructor. And let's provide getters and setters as well. So now we got entity. We also have our database. So now what we need is data access object for this database. So what we need now is local data access object, similar to the one that we are using when fetching data from the server. So we will call this data access object pictures item local DAO. Now this will also be interface, so you can notice similarities to this one in here. We want everything to be separated basically, even though it might seem like code duplication. So let's modify this like so. Now, since we are working with room database in here, we need to use DAO annotation to let room know that this will be data access object. And here we are basically specifying operations with database. First, what we want is to insert the data in our database. So how we do that? We say void save all images, and we accept list of picture item entities like this. So the magic is that basically only we need to do is to call save all images and it will be saved automatically for us. We don't need to write any query or something like that. But now, so what we have here is on conflict strategy resolution. So basically what we can do is to say replace or ignore if the room database finds out that items that we want to insert are having same IDs as the one that are inside already. So we will specify this one replace because it can happen that ID is same but the data is not. So we want to have those items updated. Other thing that we want is to get all items, but for that we need to write a query. And the query will be select all from, and the table name is picture items. So it recognized table name from here. So how cool is that? And what will this method return is list of entities. Okay, so let's rename this one also to be save all picture items. Okay, like this. So we have our local data access object. So this is how we communicate with our room database. So now where we define this data access object, how do we access it? So actually, we just put it in our database in here as abstract, public abstract, local DAO, and we say get data access object. So that's it, and the room will internally generate all implementation that pictures item local data access object is requiring. So that's pretty much all about room database. That's for this lecture, and I'll see you in the next one.